Hello everyone and welcome back to my YouTube channel. So in this new video we're gonna have a look at how to create a simple FPS controller using Unity and the C# code. So we'll be able to move using the AWSD keys and also we'll be able to jump using the spacebar button. So without any further ado, let's jump right into it. First, let's create a cylinder as our player. So in the hierarchy, let's right click 3D object and let's use a cylinder. I'm gonna call it FPS controller. Then let's go ahead and move it to this side. And I'm gonna change the Y position to 2. And let's go ahead and change the material. So I have here this red material. Let's assign it to the player. So to move a player in Unity, you have different options. You could use the rigid body component or the character controller. For me, I'm gonna use the character controller component because I think it's the easiest way to do that. So we need to attach a character controller component to this cylinder. But first I'm gonna get rid of the capsule collider because the character controller has its own collider. So let's go ahead and remove this component and let's add the character controller 1. Then we need to attach a script to control this FPS controller using the horizontal and the vertical input. And to do that, let's go ahead and create a scripts folder using right click, create folder, and let's call it scripts. And under this scripts folder, let's create our first C# script. And I'm gonna call it player movement. Then let's go ahead and attach it to the FPS controller. And I'm gonna open it up in Visual Studio. First, we need to add a reference to the character controller component. So let's declare public character controller and let's call it controller. So we are going to assign this from the inspector. Also, we need a speed variable so that we can adjust the speed of the player using public float. And let's call this speed. I'm gonna give it the default value 15. Also, we need a direction, so we need to move a player along a direction. So let's declare private vector3 and let's call that direction or move as you like. And under the update method, first we need to get the horizontal and the vertical input. So let's declare float. I'm gonna call it X to take the horizontal input. And to get the horizontal input, I'm gonna use the old input system. But if this doesn't work, make sure to watch the next video in which we are going to switch to the new input system. So let's use input.getAxis, and the axis is called horizontal. Also, let's add another one, and I'm gonna call this Z to move the player on the Z axis using the vertical input. So let's change this to vertical. Then down here, let's initialize the move vector3 using these variables. Using move equals, we can use a vector3 and set the X value and the Z value, but later on we are going to rotate the player using the mouse. So we need to make sure that the move vector depends on the player orientation, and to do that we can use transform.right and we multiply that by the X value to move the player left and right. And we need to add to that transform.forward multiplied by the Z value. And then down here, we can move the player using the character controller component and this vector using controller.move. So this method takes the direction or a motion vector3. So we'll use the move vector and let's multiply that by the speed. And also we need to multiply it by the time, the delta time, to make it frame rate independent. Now let's go ahead and save that and go back into Unity. Let's go ahead and select the FPS controller, and down here you can change the speed if you want, but we need to add the reference to the controller, and basically it's this one character controller. So let's drag it to this controller variable and let's hit play. And now I can move using the AWSD keys. So I think I'm gonna decrease the speed. So let's go ahead and change it to 12. And I think that's okay. So let's go ahead and change the value from here as well. Now I want to attach the main camera to this FPS controller. So when the FPS controller moves, the camera will move with it. So let's drag it in here. Also, let's go ahead and reset the transform, and you can adjust the height of this main camera. So I think that's okay for now. And now I can move, and we have the camera moving along with this player. But I can't rotate using the mouse, so we need to add a mouse look script to be able to look around with the mouse. And to do that, first let's go ahead and create a C# script. Under the scripts folder, let's create a new script. I'm gonna call it mouse look, and let's attach the script to the main camera, and I'm gonna open it up in Visual Studio. So we are going to use the mouse X and the mouse Y value to rotate the camera around the Y axis and around the X axis. Basically, we will rotate the player body around the Y axis using the mouse X value, and we will rotate the camera around the X axis so that we can look up and down using the mouse Y value. So let's go ahead and declare a few variables up here. First, I'm gonna add a mouse sensitivity variable so that we can adjust the mouse sensitivity using public float, and let's call it mouse sensitivity, and let's initialize it to 100 by default. Also, we need a reference to the player body using public transform. We need just the transform so that we can rotate it around the Y axis depending on the mouse X value, and let's call it player body. Then let's go down here and get the mouse X value using the old input system. So let's declare a float. I'm gonna call it mouse X equals input dot get axis, and it's called mouse X. And let's add another one for the mouse Y value, and it's called mouse Y. So to get the right input name, you could go to Edit, Project Settings, Input Manager. You see down here we have the horizontal input and the vertical one that we've used in the player movement script, and also down here we have the mouse X. So this is the string that I have used down here. Now we are going to use the value, but first let's go ahead and multiply that by the mouse sensitivity, and let's use the mouse X value to rotate the player body using player body dot rotate. So we rotate the player around the Y axis. We can use vector3 dot up, which is the Y vector, and let's multiply that by the mouse X, and let's multiply it by the time delta time as well. And now if we save that and go back into Unity, make sure that the mouse look script is attached to the main camera. Then let's go ahead and assign the player body, and let's hit play. And as you can see, I can move forward and also I can look around, but I'm only able to rotate around the Y axis. So we need to be able to look up and down using the mouse Y value as well. And to do that, let's go back to the script. Basically, we need another variable, and it's gonna be the X rotation. So let's declare a float, X rotation, and down here we are going to change the X rotation using X rotation plus equals mouse Y multiplied by the time delta time. So you're asking why I've created this X rotation for the mouse Y value and I didn't create that for the mouse X. That's because I need to make sure that the X rotation is between a certain range. For now, I will not limit the X rotation so that you can see the problem that we need to fix. And I'm gonna change the rotation of the main camera around the X axis so that we can look up and down using transform. So this script is attached to the main camera. That's why I've used transform dot look rotation, and we will set it equal to quaternion dot Euler. So we use quaternion to create rotations. So I'm gonna use the X value, which is the X rotation. So we need just to change the rotation around the X axis. And for the Y and the Z, I'm gonna leave it as default, which is 0. So let's save that and go back into Unity and let's hit play. Now I'm able to move and look around up and down and left and right. But I think I need to invert the rotation. But you notice that I can rotate over and over again. And that's why we need to limit the X rotation. So to fix that, let's go over here And before we change the rotation of the main camera, we need to make sure that the X rotation is between two values using X rotation equals, and we can use the mathf dot clamp. So we need to make sure that the X rotation is between, for example, minus 80 and 80 degrees. Now the problem will be fixed. Also, I want to hide the mouse, and to do that we need to use cursor dot look state equals cursor look mode dot locked. Now let's save that and go back into Unity, and let's test this again. But I think we have an error. That's because this method takes the value that we want to limit, which is the X rotation. That's the first parameter, and then you can put the limits that you want to add to this value. So this X rotation needs to be between minus 80 and 80 degrees. So let's save that again. And yeah, now it's working. I just need to invert the rotation of the camera around the X-axis. You could make it as an option as well. So let's go ahead and invert that, and it's very simple. We need to use minus equals the mouse Y value multiplied by the time to delta time. Finally, I want to add the jump ability. For now, we can't jump. We can just move using the AWSD keys. So to do that, let's go ahead and add few variables like the gravity and so on using public float, and let's call this one gravity. I'm gonna initialize it to minus 10 by default. Also, we need a velocity vector using private vector3 velocity, and also we need a jump force. So let's declare public float. I'm gonna call it jump force. Let's give it the default value 8. But also we need a way to check whether the player is on the ground or not. And for that, I'm gonna use a ground check empty game object. So let's go back to the player. Then let's go ahead and create an empty game object using right click, create empty, and let's call it a ground check. Then we need to put it under the feet of the player. So I'm gonna change the Y position to minus 1.2. So basically we'll use physics.check sphere. It's going to create a sphere, and if it's touching a ground or something that is called the ground, in that case it's going to return true, otherwise it's going to return false. So let's go ahead and add few variables down here. First, we need a reference to the ground check empty game object using public transform, and let's call it a ground check. Also, we need to define a ground layer using public layer mask, so the type is layer mask, and let's call it a ground layer. And finally, let's add the boolean private bool, and let's call it is grounded. And to get the value of the boolean is grounded, let's go down here in the update method. So let's use the built-in function or method, which is under the physics.check sphere. So this method takes three parameters. The first one is the origin of the sphere, which is gonna be the ground check position using ground check dot position. Then we need to give it the radius, maybe 0.4 or 0.3. And finally, we need to add the layer mask, which is the ground layer. Now this method will return true if the sphere with a radius 0.3 hits something that has a layer ground, or we can define this ground layer from the inspector. So for example, if the sphere hits the player, we don't need to return true because the player can be on the ground or not. So let's go ahead and make a debug.log for now using debug.log, and let's output the boolean is grounded. Then let's hit save. So let's select the FPS controller. Then we need to drag in the ground check under this ground check variable, and here we need to define the ground layer. Basically, we need to create a new layer and assign it to all of the objects that is supposed as ground, like the base of the level, basically all of the objects inside this map empty game object. So we need to create a layer and assign it to all of these objects except the player, of course, because the player is not a ground. So let's select all of these, and over here let's go ahead and create a new layer. I'm gonna call it ground. Then let's go ahead and assign it to all of these. From here, let's change the layer to ground, and then we need to make sure to select that layer under this ground layer variable. And I think that's pretty much it. So let's hit play. By default, the boolean is true because the player is on the ground, of course. But if I move it, for example, let's move it from the inspector along the y-axis, you see that the boolean is false under the console. So it's working. Now we are going to use this boolean down here. So to jump, we need to check if the player is on the ground. So if it's grounded true, in that case, we can check if we hit the jump button using if input dot get button down, and it's called jump. So this is for the spacebar button. In that case, we need to call some kind of jump function. It's not created yet, so let's create it over here. You could place all the lines of code under here, but I'm gonna create a separate function to make things cleaner. And let's make it private void jump. And to jump, it's very simple. We need to change the velocity y value using velocity dot y equals a jump force. And also we need to use the controller to move the player using this velocity vector. So let's go down here and use controller dot move. So we give it the velocity, and let's multiply that by the time delta time to make it frame rate independent. But also we need to make sure to add the gravity to the velocity. So let's go ahead and use velocity dot y plus equals the gravity, and let's multiply that by the time delta time as well. But we have one problem. So here we are decreasing the velocity dot y value all the time. So we need to make sure to decrease this only when the player is not on the ground. So we can add an else over here. So if the player is not on the ground, that means that he's jumping. In that case, we need to add the gravity. But if the player is on the ground and the y velocity is negative, we need to reset it to 0. So let's add it over here. Make sure to add it before this jump, or you will reset the y velocity before jumping. So let's go over here and check if is grounded is true. And the y velocity using velocity dot y is negative. In that case, we need to reset it to 0 or give it a smaller value using velocity dot y equals, let's give it the value -1. Now let's save that, and I think that's pretty much it. So let's go ahead and test our game. First, I'm gonna go to the game view and let's maximize that. And there you go. I can move and I can look around with the mouse, and also I can jump using the spacebar button. Maybe we need to adjust the gravity and few other variables, but we have one problem. I can't go upstairs, so we can simply fix that by modifying the slope limit. So let's go ahead and fix it. You can select the FPS controller, and under the character controller, let's go ahead and increase the slope limit to 90 degrees, and the problem will be fixed. Finally, I want to show you another trick. So instead of using a jump force, you could specify the height. So let's go ahead and declare a height variable. Over here, let's declare jump height, and let's give it the value 2 meters. And then down here, instead of using the jump force, we can use the square root of the height multiplied by 2 multiplied by the gravity. That's how physics and math work together. So let's use mathf. This is the square root method. And let's give it the jump height multiplied by 2 multiplied by the gravity. And because the gravity is negative, we need to add -1. So let's save that. And now we can specify the jump height instead of jump force. You could change few settings from here, like the gravity. I think I'm gonna increase it. Maybe the speed, let's change it to 10. Let's maximize this window and hit play. And yeah, it's working. We've created an FPS controller using the C# code. I can move and I can look around. Also, I can go upstairs and I can jump. So that's pretty much it, guys, for this video. I hope you enjoyed it. If you have any question or comment, make sure to write it under the comment section down below. Also, make sure to hit the subscribe button and ring the notifications bell so that you don't miss any one of my next videos, and I will see you in the next one.